this is lesson 5.1, and in this lesson we're going to do an introduction to quadratic relations. The graph that characterizes a quadratic relation is a special curve called a parabola. And the equation that expresses a parabola looks like y equals ax squared plus bx plus c. And the key here is this term, ax squared. Because if we ignore that term, we just have y equals bx plus c, which is very much like the equation of a line, y equals mx plus b. It's just different letters in front of the x and after the x. But it would just be a line. This ax squared term is what makes it a quadratic relation, that x squared term. The parabolic curve is very common in sports, engineering, and everyday life. A quadratic curve is a symmetrical curve. So if I show you these pictures down here, I'm going to show you a couple places where we have a quadratic curve. So this sky arch is a parabola. It's a quadratic curve. The curves that are quadratic are symmetrical. When you launch a projectile like this cricket ball, the path that a ball follows in the air is also quadratic. The arch of a satellite is quadratic. We have two here. And the wires on a suspension bridge follow a quadratic curve, or a parabola. And there's this guy here, just kind of fun, like his hat or his nose or the water. We all have those curves. There's a few more important features of parabolas that we're going to get into a little bit later, but for now we just need to understand that it's a symmetrical curve. Then I just said, what other parabolic curves can you think of? Where else can you think of other parabolas? There's one that occurs fairly regularly in nature, a rainbow. Also a half pipe. And if you can think of any more, you can add them to the list. And the completed handout has a few more examples on it if you want to check those. All right, let's flip the page. So let's graph our first parabola. We're going to start with the simplest parabola, the y equals x squared parabola. And what we're going to do is we're going to take some x's, plug them into our equation for x, solve for y, and use the x and y pairs as a point, and we're going to graph our first parabola. So I'm going to have my calculator here. So what we're going to do is we're going to square all of our x's. We're going to start with -3, we're going to go all the way to 3. So our first one, if we want to find y, we're going to take our -3 and we're going to square it. The brackets are pretty important here because we're squaring the whole number -3. If you just type in -3 and square, it might just square the 3 and keep the answer negative. But our answer is not going to be negative because a negative times a negative is a positive. We end up with 9. So the first point on our graph is -3, 9. And if we keep going down the chart here, next will be -2 squared. We would get 4. So we have -2, 4. And then we have -1 squared, which would give us 1. So we have -1, 1 as our next point. Our points are coming from our x and our answer, y. The next one will be 0 squared. If we square 0, we just get 0. And then something neat starts to happen. Remember these numbers, 9, 4, 1, and 0. If we square 1, we get 1. So 1, 1 is a point. If we square 2, we get 4. So 2, 4 is a point. Look at the numbers. 1, 1, 4, 4. 0 is in the middle. You might be able to guess what we're going to get at the end. 3 squared is 9. So why does this happen? Well, because there's two different ways to get the number 9. We can square negative 3 or positive 3. They both give us the same answer. If we square 2 or negative 2, we get the same answer 4. If we square negative 1 or 1, we get the same answer 1. If we square 0, we get 0. So the reason why the numbers repeat in the table is because squaring different numbers can give you the same answer, the negative and positive version. All right, let's graph these dots. Negative 3 gave us 9. Negative 2 gave us 4. Negative 1 gave us 1. 0 gave us 0. 1 gave us 1. 2 gave us 4. And 3 gave us 9. And what we have here is 9 dots, and these 9 dots represent a parabola. So I'm going to connect them. I'm going to start by connecting them from this dot at the bottom here. Makes it easy to connect the dots. And I'm going to put arrows to show that this graph would continue. And there we have our first parabola that we've ever graphed, y equals x squared. So this is the simplest parabola that you can graph, and the reason it's the simplest is because it has the simplest equation. The x squared part of the equation has to be there to make it a quadratic, and we have nothing else in the equation to change our parabola, so we just have the simplest parabola. Let's go to the next one. In our first example, we have the equation y equals negative x squared plus 8. And how we know that this is a parabola is the x squared term. Because we have an x squared, we know we're going to get a parabola. And because our equation has more than just the x squared, we know our parabola is not going to be the simple parabola we just graphed. This parabola is going to look a little bit different, but it's still going to be the same type of curve that's symmetrical. So let's see how it looks different. We're going to use the same x's, and we're going to plug them into our equation. We only have one term with an x, so we only have to put the negative 3 in one spot. It says negative, and then we put negative 3 and square it, and then add 8. So what do we get? Well, let's use our calculator. So we've got negative bracket negative 3 squared, x squared button, and then add 8. It's really important that when you substitute or replace the negative 3 into an equation, you do it in brackets. Notice this equation is the exact same as what's written here. The only difference is instead of x, I write a bracket with the number I'm replacing. It equals, we get negative 1. So one of our points is negative 3, negative 1. And we do the same thing with 2. What I'm going to do is I'm just going to go back here. I'm going to delete the 3 and make it a 2. And I have the exact same equation. I'll have to type the whole thing in again. 4. And that was negative 2 squared plus 8. We got 4. So negative 2, 4. Let's try 1. We get 7. So if I plug in negative 1, I get 7. And if I put in 0, might be able to do this one in our head. 0 squared is 0 times negative 1 is 0, so we're just left with this 8. Let's try 1. And this is where we might start getting some of the same numbers again, because squaring negative 1 gives us the same thing as squaring 1, 7. Once you identify the pattern, you don't have to do the calculations anymore, because if you look -1, 4, 7, 8, back to 7, the next one's going to be 4 and -1. They're going to be symmetrical. That's the property of a parabola, is that they're symmetrical. And now we can graph our dots. -3, -1, -2 and 4, -1 and 7, 0 and 8, 1 and 7, 2 and 4, 3 and -1. Notice this parabola has a peak instead of a valley. So this parabola is going the other way. Extend it a little bit past our last dot. This parabola is going down. And there we have it. -x² plus 8 goes down. And what we're going to realize in a little bit is that the sign in front of the x² will tell you which way your parabola is going to open. So if we look at this one, this parabola has an opening up, and the sign in front of the x² is plus. The second parabola we just graphed is opening down. The open is down, and the sign in front is negative. And this is called the direction of opening, something we're going to look at in the next lesson, and there's a really easy way to remember it. The plus sign in front of the x² is positive. Positive people smile. This looks like a smile. Negative sign in front of the x², negative people frown. When you frown, it opens upside down. Okay, that's it for our first lesson. Thanks for watching 5.1, and I'll see you next time.